The directions here say to write each expression in radical form and simplify if needed. So all of these expressions have what we call a rational exponent. The rational exponent means that there's a fraction. They're all raised to a fraction. So we're going to write them in radical form. We're going to use those rules that we just did at the top of the page and get them in radical form. So x to the 1/4, if I'm going to turn that back into radical form, remember the number on the bottom is the root. So this is the same thing as writing the 4th root of x. And that's it, because it's x to the 1st, okay? So really there's like a 1 right there. We just don't really write that 1 in algebra, okay? So it's x to the 1st, but it's actually the 4th root of x. So that's all you would need to do to put that into radical form. 15n to the 1/2, okay? So the 15 and the n are both raised to the 1/2 power. The number on the bottom is our root. So the 2, that's my root. So it's a square root, okay? So this is going to be the square root of 15n. And I don't need to worry about the 1 because these are both raised to the 1st power. We don't write the 1. And I also don't necessarily need to put the 2 out here because we assume that when a root is here, it is our square root. If it's anything other than the square root, that's when we put the root there. But if it's the square root, you don't necessarily even need to write the 2 there because it's the assumed root. So we have just the square root of 15n. The next one says 24 to the 1/3. And if I'm going to put this back into radical form, the number on the bottom is my root. So this is a cube root. So this is going to say the cube root of 24. And it's 24 to the 1st, but again, we don't need to put the 1. Now, the cube root of 24, you can check it in your calculator. If the cube root of 24 was a nice integer number, we would want to go ahead and simplify that, okay? But the cube root of 24 is not. If you take the cube root of 24 in the calculator, you get a decimal. And so we don't want to put decimals here. We're just going to leave the cube root of 24 as is. 7 to the 2/3. Well, that is, the root is 3. The number on the bottom is always the root. So we can do this 2 ways. We can either write it the cube root of 7 and then square the whole thing, okay, and that's fine. Or we can write it as the cube root of 7 squared, okay, which is also fine. And I'm just going to leave it there. I'm not going to go any further. I know that 7 squared is 49, but we're just getting these back into radical form. And then because the square root of 49 then isn't going to simplify either. So let's just leave this as is because either one of these solutions is fine. Okay. K to the 7/2. All right, this is the square root because the number in the bottom is the root. So it's a square root and it's raised to the 7th power. So I'm going to write this one as the square root of k, and then I'm going to raise it to the 7th. Okay? You could also write it the square root of k to the 7th. Okay? Either way is fine, and I don't care which way you do it. I'm going to try when I put the answers in GoFormative to put them in there both ways because either way is okay with me. All right, 3 to the 5/4. The number on the bottom is the root. So this is the 4th root of 3 to the 5th, or the 4th root of 3, all then raised out here to the 5th. Again, either way is fine. AB to the 3/4. Now, this is one where I want to be more particular, and I don't want to do it either way because there are 2 things that are going to be underneath my 4th root. Okay, when there are 2 things that are going to be underneath your 4th root, I want to pull it all outside with the parentheses. So I'm going to write this one as the number on the bottom is the root. The 4th root of AB, okay, it's all underneath the root, and then I'm going to raise the whole thing to the 3rd power. -6x to the 2/3. Okay, again, I'm going to do this one kind of like I did the last one. Since there's kind of multiple things happening underneath what's going to be my cube root, I'm going to use the parentheses and put my 2 on the outside. So this is the cube root. The number in the bottom is the root of negative 6x. And then I'm going to raise the whole thing to the second. Oh, this one's a little bit harder because I have this 7 out here that doesn't have anything to do with my rational exponent, okay? The 12 is being raised to the 1/2. The w is being raised to the 1/2, but the 7 is not. So we just kind of have to leave it there and work it through with our answer as we move along. So when I do this one, I know something raised to the 1/2 means it's a square root, okay, because the number on the bottom is the root, and so it's a square root. So I'm going to say 7 times the square root of 12w. And the square root of 12 simplifies. And so I need to simplify down the square root of 12, okay? Remember to do the square root of 12. It's 2 times 6, which is 2 times 3. And then I need a pair to pull 1 out. And I definitely have a pair of 2s. So I have this 7 on the outside. I have this pair of 2s on the outside. The 3 and the w both stay under the root. And then I go back and multiply the 7 times 2 and get 14 square roots of 3w to simplify that one all the way down. Now, the reason I didn't do the breakdown any of the rest of these, well, square root of 7 doesn't, cube root of 7 doesn't break down any further. The square root of 15 doesn't break down any further. Cube root of 24, that's a decimal. It doesn't break down any further. So you only want to do this simplifying if you actually can, okay?